I think we are live. बोल दे भाई टेस्ट टेस्ट.
Check, check, check. Check.
Okay, आ रही है. दोनों की आ रही है आवाज. We can start it. All right. So okay. So welcome back, everybody. Um, we are continuing our work on the OpenUSD certification. We're trying to get our OpenUSD certification. As you already know, we are trying to build our startup, which is called InstruX, and it's basically an end-to-end workflow dashboard for agent orchestration. Um, this is how it's gonna look when it's complete. This is just a vision for right now. So as you know, that an important concept or phenomena or what do you say, framework to do all this stuff is OpenUSD, Universal Scene Description. Um, so yeah, we have completed the overview. We completed the stage in this first module, and now today we're gonna go in depth of what prims are. And but a side note for that today is there's a new paper which came out not too long ago. It came out on 17th February 2026, which has been like a leap in action models. And it is basically shifting the paradigm from visual language action models to now completely world action models, which are creating these zero shot policies for the robots. Um, so yeah, we're gonna start reading this paper as well today, and hopefully, you know, get somewhere with it and understand what the implications of these papers on our startup would be, and how we're gonna use these models and incorporate them in our pipeline. Um, so yeah, do you want to add something out there?
No, I think you have pretty much summed up everything that we are gonna do today.
Yeah,
So I think let's get started then.
yeah, and let me just also open up this dude's
I think I'm not able to
dream.
see
Oh wait,
something.
1 second, 1 second. Cool. Do you see it now?
Yeah.
Okay, dream zero. .github.io. I'm not able to copy this shit. Okay, let it be. So let's get started with world action models. World action models are zero shot policies. These are some of the contributors over here. Project leads and core contributor was dreamer0.github.io. This was his GitHub. I don't know. I can't open it for some reason. This is the one. Um, NVIDIA Dream Zero world action models are zero shot policies. Dream Zero is a world action model that jointly predicts actions and videos, achieving strong zero shot performance on unseen tasks. This release packages contains everything needed to load a pre-trained Dream Zero model and run distributed inference via WebSocket server. So this is a really important repository for our pipeline. We can also
Mm-hmm.
create a fork. I don't know why I clicked on that. I was trying to start it. Yeah, cool. So let's just take a look at the figure that they've provided us with over here. bimanual mobile manipulation, task diversity, repetition, fruit packing, table bussing. I don't know what that is. Video language, proprio, world action model, future videos, continuous actions, bimanual arm, human. hmm Okay. So in this figure, they are trying to jointly predicting the video and the action. World action models, WAMs, inherit world physics prior that enable effective learning from diverse, non-repetitive data. Open world generalization, cross-embodiment learning from video-only data, and few short adaptations to new robots. Okay. Um, let's see. Okay, let's start with the abstract. Do you want to read the abstract?
Yeah, I can go ahead and read the extract. So yeah, abstract talks about the state of the art vision language model, that is VLA, that excels at semantic generalization but shouldn't generalize to unseen human emotions in novel environment. Basically, what it's saying that if you give a model generalize a scenario and train over it, let's say picking up an object or picking up or maybe identifying something, right? And if he has already seen it, then it will be able to do it. But if that object is some that object is something different, or the model has not seen it, it's not able to perform that that great, I would say. So over here they have introduced Dream Zero, a world action model built upon a pre-trained video diffusion backbone. So unlike VLAs, WAMs learn physical dynamics by predicting future world states and actions, using video as a dense representation of how the world evolves by jointly modeling video and action. Dream Zero learns video skill effectively from heterogeneous robot data without relying on repetitive demonstration. This results in over 2x improvements in generalization to new tasks and environments compared to the state of the art VLAs in real robot experiments. So, crucially, through the model and system optimization, we enable a 14 billion autoregressive video diffusion model to perform real time closed loop control at 7 Hz. Finally, we demonstrate two forms of classic embodiment error. Video only demonstrations from other robots or humans yield a relative improvement of over 42% on unseen task performance with just 10 to 20 minutes of data. More surprisingly, Dream Zero enables few shot embodiment adaptation, transferring to a new embodiment with only 30 minutes of play data while retaining zero shot generalization.
Okay, let's go to the notebook LM to just understand what the application basically are. Okay, so it basically introduces the Dream Zero model, a pioneering world action model developed by NVIDIA that integrates video generation with robotic control. Unlike traditional models that focus solely on mapping images to actions, Dream Zero simultaneously predicts future videos, frames, and motor commands. So this is pretty interesting, allowing it to inherit deep physical intuition from massive web scale video data. So basically, let me also show that Sequoia thing. I don't know why I thought that it had some stuff about World Action Model, but anyhow.
No,
Uh
it does have some stuff about it, but like
oh,
you
here
can't
it
go.
is. Oh, yeah, yeah, yeah. I found it. Found it.
I know it does have some about stuff about it.
Yeah. Dream Zero. Yeah. Yeah. So if the video prediction works, the action works.
Yeah.
Wait, what was so this was something really important that he said over here. Vision and action are now first class citizens.
VLA rep. Bye bye in the loving memory of.
That was a little bit about the Dream Zero thing over there. Uh so let's quickly read this. Unlike traditional models that focus only on mapping images into actions, okay, Dream Zero simultaneously predicts future video frames that motor commands, allowing it to inherit deep physical intuition from massive web scale video data. This architecture enables the robot to achieve zero shot generalization, performing entirely new tasks and navigating unfamiliar environments without requiring specific prior demonstration through significant system optimizations. The researchers achieved 38 times speed up in processing, allowing a massive 14 billion parameter model to operate in real time at 7 Hz. The study also highlights remarkable cross embodiment transfer, showing that the model can learn from human videos or adapt to entirely different robot hardware with minimal data. Cool. Ultimately, the results demonstrate that modeling the visual future of the world is a more effective way to teach robots complex, non repetitive physical skills than standard imitation learning. That's what we were trying to do. So this line is really important. Ultimately, the result demonstrates that modeling the visual future of the world, basically synthetically generating and simulating the actions, is more effective way to teach robots complex, non-repetitive physical tasks um, than standard imitation learning, which is like wearing a lot of gear and doing all sorts of imitation learning and performing all sorts of teleoperation tasks for the data aggregation and then feeding it into the model and stuff like that. So what the abstract of that thing just says is current robot foundation models, known as vision language action models, are like book smart students who understand the concepts perfectly but lack the physical coordination to perform the brand new sport in an unfamiliar environment. They know what an object is but struggle to generate new physical motions they haven't practiced before. Okay. So they basically know what the environment is, what the object is.
Well, if you tell a model that pick up a dumbbell and train on it, it's going to train on it. If you change the dumbbell to something else
Right,
pick it up,
right,
it won't be able to pick it up. That's that we have.
right, right. So instead of just memorizing specific muscle movements, Dream Zero used a video generating brain to predict how the physical world will look in the future and tightly links that visual imagination to the physical actions required to make it happen. So basically, if you remember the graph we were talking about the other day when we were watching that Groot model video, where it was predicting the vectors of the future, I don't remember exactly what that graph was, but basically what they're trying to do is using those simulations, or that the future frames, they are basically also predicting the motors, floating point vectors, uh, on the graph for the robot to perform those physical tasks. So I think they should have given us a graph like that over here somewhere. What was that graph? Do you remember? The vectors that we were watching on the Groot video,
The vectors we watched on a group video.
the floating point vector thing that it was trying to imitate.
Let me take a look. Well,
Wait, I think
let,
there was a graph somewhere.
and that might be ahead. Like if you're talking about comparison with VLM, right? It's gonna be more.
Ego scale.
Ego skill.
Cool. So to solve this, researchers introduced Dream Zero World Action Model that acts as like an athlete who mentally visualizes a successful play before moving. Instead of just memorizing specific muscle movements, Dream Zero uses a video generating brain to predict how the physical world will look in the future and tightly link that visual imagination to physical actions required to make it happen. Because it understands the physics of how the world evolves, Dream Zero offers several massive advantages. Learning from pickup games, not just repetitive drills. It learns diverse skills from messy, varied real world data without needing to be shown the exact same repetitive demonstration over and over. Twice as adaptable. When placed in a brand new environment and asked to perform a totally new task, Dream Zero performs over twice as well as previous state of the art models. Split second reflexes. Even though imagining future videos frames takes a lot of computing power, the researchers optimize the system so the robot can think and act in real time, 7 times per second without freezing up. Got it. Got it.
Learn
Cool.
by
10 to
important.
yeah, 10
All
to 20
that.
minutes of showing a a human or different robot performing a task. It acts like a player studying the game tape, boosts its own performance and unseen tasks by over 42%. Instant body swapping, most surprisingly, if you take Dream Zero's brain and put it into a completely new unfamiliar robot body, it only takes 30 minutes of unstructured playtime to figure out its new limbs and immediately start succeeding with tasks it never seen before. Ooh, chitty boy chitty robot. Okay. Built upon pre-trained video diffusion backbone. What does this mean exactly?
So there is only one answer out.
Also, let me know when you want to switch to prims if this gets very long.
But this is gonna get very long. I think after the abstraction, we can move
Abstract and let's say a couple of more pages.
a couple of more pages. At the speed we are going, I think we won't be able to do prems today.
I will make it happen. Inshallah.
I I don't have time. That's what I'm saying. Like you already have time. We already way deep in. That's what I'm saying. That either we complete stop at abstraction and then we will
Okay,
go.
cool. Okay, we'll stop at abstraction and abstract and yeah. Okay. So, in context of the paper we are reading, Dream Zero Pre-trained Diffusion Backbone refers to the core underlying engine that researchers use to build their AI. To break down simply, in AI architecture, a backbone is primarily primary model that handles the heavy lifting of understanding data. Instead of building a robot brain from scratch to understand what gravity or a hand looks like, the researchers used an existing powerful model, in this case, WAN 2.1. What's WAN 2.1?
I think the world action model.
No. AI video generation model.
Hmm.
Bruh.
Yeah.
Okay, they used WAN 2.1 as the starting point. Diffusion is this is the same technology behind image generation, DALL-E and Midjourney. It works by taking random noise and denoising it step by step until clear image emerges. Video diffusion model doesn't just create one image. It creates a sequence of frames that mathematically consistent over time. It knows that if a ball in the air is in the frame one, it should slightly lower in frame two. Oh, okay, okay, okay. So it basically applies physics to those frames.
Okay, it doesn't create an image, it creates a sequence of frames that are
Mathematically consistent over time.
it's all machination,
It's
mathematical precision.
all mathematics at the end of the day, bro. Oh, damn. This is the most critical part of the paper because the models was pre-trained on millions of hours of internet videos, people cooking, walking, objects falling. It already has a common sense of understanding of world physics. Why this matters for the robot? Traditional robots are usually taught via imitation learning. Monkey see, monkey do.
Yeah,
If they
monkey
yeah,
doesn't do.
yeah, if they haven't seen a specific task 1,000 times, they fail. By using a video diffusion backbone, Dream Zero acts differently. It imagines what the success state looks like. Okay, because the backbone understands the physics from its pre-training, the robot's actions are then calculated to match that imagined video. Bro, this is amazing. Cool. Instead of teaching a child exactly which muscles to move or to throw a ball, you show them a video of pro pitcher. Because the child already understands how the arms and the balls move in the real world, their pre-trained backbone, they can figure out the motion themselves. That is how the robot is trying to do those autonomous tasks. Okay. Unlike VLAs, WAMs learn physical dynamics by predicting future world states and actions using video as dense representation of how the world evolves. Correct. By jointly modeling video and action, Dream Zero, jointly modeling video and action, Dream Zero learn.
Have merged, I think, VLAs and WAMs into WAN, that is World Action Model.
Mhm. Um Dream Zero learns diverse skills effectively from heterogeneous robot data without relying on repetitive demonstrations. This results in over 2 times improvement in generalization of to new tasks and environments compared to state-of-the-art VLS in real robot experiments. Crucially through model and system optimizations, we enable a 14 billion autoregressive diffusion video diffusion model to perform real-time closed loop control at 7 Hz. What is this line? 2 times improvement in generalization to new tasks and environment compared to state-of-the-art VLAs in real world. Okay. Crucially, through model and system optimizations. Through model and system optimizations, we enable 14 billion autoregressive video diffusion model to perform real-time closed loop control at 7 hertz. Closed loop control at 7 hertz. Okay. So this is basically performing the action at 7 hertz, right?
Mhm.
Finally, okay, so what I want to understand here is in context of Dream Zero, the 7 hertz figure refers to frequency at which AI model can observe the world and send new command to the robot. Here is the technical breakdown in engineering. Hertz is the cycle per second. Yes. 1 out of 7. So 143 millisecond. 1 by second. 1 by 7 seconds. So this means the entire thinking process, thinking in camera.
Oh, I see. I see. It takes only 143 milliseconds. Hmm. But why is it controlled at 7 hertz?
This means the entire thinking process, taking the camera frame image, imagining the future video, and calculating what happens in about 143 milliseconds. Oh, for the robot to be safe and effective around humans, moving objects, it needs to react quickly. While 7 hertz is slower than humans' nervous system, which can be much faster, it is fast enough for the robot to successfully handle dynamic tasks like picking up moving object or adjusting its grip if a shirt slips while folding. Usually diffusion models like the ones generate image or video are incredibly slow. They often take several seconds or even minutes to denoise an image. The research behind Dream Zero used several tricks to get massive 14 billion parameter model to 7 hertz. KV caching, reusing previous thoughts so it doesn't have to reprocess the entire video history every time. Dream Zero Flash, a specialized training method that allows the model to predict an action in just one or two steps instead of the usual 16 step required by standard diffusion. Using the previous thought so it doesn't have to process. Okay. Finally, we demonstrate two forms of cross embodiment transfer. Video only demonstration from other robots or human yields a relative improvement of over 42%. What does this mean?
It says, right, the researcher behind Dream Zero used several tricks to get a massive 14 billion parameter model. Okay, now that's fine. Finally, we demonstrate two. All humans. Are they comparing them with humans? I'm assuming that now. Because it says video only demonstrations from other robots or humans yield a relative improvement of over 42% on unseen task performance within just 10 to 20 minutes of the data.
Oh, recorded demonstrations, like humans doing the actions.
Oh, yeah, yeah, okay, then that makes sense. That makes sense. Yes, yes, yes.
So cross embodiment transfer means video only demonstration from other robots or humans yield a relative improvement with just 10 to 20 minutes of data using Dream Zero. More surprisingly, Dream Zero enables few shot embodiment adaptation, transferring a new embodiment with only 30 minutes of play data while retraining zero shot generalization. Yes, I understood this. Okay, abstract is complete. Now what do you want to do?
Let's do prems.
Cool.
Or let's go with our LM notebook, right? In our LM notebook, we have our complete setup, right? So let's ask LM notebook.
But we need to read prems right first before
No, no,
taking
just
the quiz.
no, no. Let's go with this, right? Let's go with this.
But what do you want to
Let's
do over here?
go down. Go down in the chat. Oh, wait. Oh, in the chat. Oh, my bad. So in the chat, you the type we are trying to learn prems. Help us to learn prems today. We have already covered staging.
Overview.
Okay. Yeah.
Wait, let me also give it the prems.
Dude, it already has the study guide. Oh, wait. Don't give anything right now. It
No,
already
no,
has
no.
the.
That study guide is like it's not like it's not the like the module, bro. It's just the weightage
Are you
and.
sure? No, no. I think it has everything.
But let me like, what's the harm, bro? Like, let me just give it.
Like it's gonna hallucinate at that point, right? Wait. Don't put it right away. Don't put it right away. I want to see what it gives us, right? Let's see.
Oh, so this is the thing. Certification sample questions.
Prim building blocks that represents every single element within your open scene. Scene. Okay, when you load an OpenUSD stage, it acts as a top layer that organizes a hierarchy of prims.
Bro, fix your mic. Fix your mic first.
Wait, my mic is pretty good. I can hear it clearly, and I can see the motions over here as well. Dude, are you able to hear my voice or not?
Yeah, but it's like breaking a lot. Not your camera, bro, just your mic. Just turn on and off your mic or something.
Uh, hello, 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 hello.
Yeah,
Uh,
it's
is it
fine.
good? Okay. All right. So prims are the fundamental building blocks that organize every single element within any OpenUSD scene. Right. When we load the OpenUSD stage, it acts as a storage container. I think this is all the things that we
Bro, your voice is breaking a lot. Like, I think you're. 1 second.
dude. Is it VD OpenUSD?
Yeah, probably.
Wait, I think I have an.
Oh, your network is very bad on like in the Video Ninja. Your thing has like red bars connection.
Now how is it?
It's still red. Try joining again. Like try to join. Yeah.
Hello, hello.
Yeah.
How is it? Hello, hello, hello. Is all
Yeah.
clear?
Yeah. Much better.
Check,
Much
check,
better. Yeah.
check. All right, let's go. So, prims are basically the fundamental building blocks. So, can you do a split window in Chrome and open the prims documentation? Yeah, new split window. There we go. What the?
Cool. Let's watch this once again.
I think AI describes this thing. Prims are the fundamental building blocks. What the fuck are you doing, man? Non-imageable, mesh, light, skeletal.
position, rotation, scale, material information, animation data, and more. These properties define the attributes and relationships of the objects they represent. A key feature of USD prims is their ability to encapsulate data, allowing them to be shared, referenced, and instanced across different scenes and files. This promotes efficient data management, modularity, and collaborative workflows. Typical use cases include defining models, cameras, lights, or even groups of other prims. The ability to efficiently manage and manipulate these prims non-destructively is what makes USD so powerful in the film and gaming industries, where complex scenes are the norm. In Python, working with prims involves several commands using the USD Python API. This generic USD API command is used to define a new prim on a USD stage at a specified path and optionally the type of prim. This command, specific to the USD geom schema, is used to define a new prim on a USD stage at a specified path type X form. Retrieves the children of a prim, useful for navigating through the scene graph. Returns the type of the prim, helping identify what kind of data the prim contains. Returns all properties of the prim. Today, we covered what a prim is in the context of OpenUSD, its characteristics, and its role in building and managing 3D scenes. We also looked at how prims facilitate data encapsulation and sharing, which are critical for complex 3D project workflows. Understanding prims is foundational for anyone looking to work with USD in any capacity. Thanks for watching. If you'd like to learn more, check out the following resources and we'll see you soon.
Cool. Nice. Okay. So I'll just quickly read through the documentation, rest of the documentation, and we can start working on whatever we have the doubts on, and then quickly spin up a quiz and go through that. So a prim is the core component within a USD framework that we know. Think of prim as the container that holds various types of data, attributes, and relationships which define an object or entity within a scene. Cool. Attribute. An attribute is basically a property that holds type data value that can vary over time or have a single default value. Relationship is property that establishes pointers or links between prims and properties in the scene hierarchy. Okay. Attribute. What that holds typed data values that can vary over time or have a single default value. Yeah, cool. A prim can be type of visual or non-visual entity, such as mesh or material, or light or an X form. Dude, I'm still a little bit confused about what exactly an X form is. I want to understand this.
Dude, I have a API, complete different API. Like it's gonna teach you in the features. I know it's gonna teach you in the features.
Mm-hmm.
X form is an API geometry that you can use to do transforms and all.
Okay. So mesh, material, and light, I understand, but I don't understand what is an X form over here. And I keep seeing X form everywhere. Like whenever we generate a USDA file, even over here, it starts with an X form, def X form world, and I don't understand why it's doing that. But let's keep going. It's gonna, show us in a bit. Where were we? Okay. So prims are organized in a hierarchical structure, creating a scene graph that represents the relationship and transformations between objects in the scene. Okay. Each prim has a unique identifier known as path. Okay. Each prim has a unique identifier known as a path. Cool. Path is the location identifier in USD namespace represented by SDF paths class. Okay. So it showed us something over here. Oh, 1 second. It basically taught us XForm before when you gave it that prompt. XForm is a specific type of prim used for spatial transformations, while the deep definition of XForm came outside these current sources. Okay, it's gonna come in the future.
That's what I said, bro. That's what I said.
Okay, let it be. So, prims are organized in a hierarchical structure, creating scheme graph. Okay, each prim has a unique identifier known as path, which helps locating it within the scene graph. For example, prim's path might be world building geometry building geo, indicating that it is a child of geometry. Okay, which itself is a part of building A prim, and so on.
Mm-hmm.
Okay, prims can have various types of attributes associated with them, such as position, rotation, scale, material information, animation data, and more. Cool. These properties are define the attributes and relationships of the objects they represent. Cool. A key feature of USD prims is their ability to encapsulate data, allowing them to be shared, referenced, and instanced across different scene files. Typical use cases include defining models, cameras, lights, or even group of other prims. The ability to efficiently manage and manipulate these prims non-destructively is what makes USD so powerful. Okay, cool. Working with Python, generic USD API used to define when a new prim on stage at a specified path. Excuse me. Mm-hmm.
Why are you typing the same thing again and again?
I'm not typing, bro. It was the same prompt that has been going on for a long time.
Oh,
I don't know why it got stuck over there, but anyway. Okay, so can you explain the code over here?
yeah, I think over here, as you can see, we are first defining our prim with path as an argument and the prim stage dot define prim. And then second, we are moving on to specific to USD geom. So this is what I was talking about. You're telling me, right? Hey, what is the use case of XFOM? Over here, as you can see, there's a library called USD geom dot XFOM dot define. So here is where you define XFOM and then you define your stage and the path for that XFOM, right? So we will see more examples in the future, but for now you can just take it as like that. That okay, this is one of the use case of XFOM where you're using it right now. And then we have other, I think, prim functions, that is prim dot get children, because our consists of uh, like I think it's, how would I say, children, yeah, children basically. So prims do consist of children, basically things that are inside the prim. And then we have, what is this, we have returned the type of the prim. So if we use get type name, we get the type name of the prim. And then we have prim.get properties. So what we can do is we can just spin up our local IP and IPYNB notebook and test it out. That would be it. Or over here they have basically copied my notebook again. You can run this example, this Jupyter notebook, see how. Saying see how.
Mm-hmm. Okay, which one?
So like, yeah, I think this one would do. You see over here, it's defining prim. So we have our world as our path, It would go up. This is the one. I think over here we are defining the prim. This is the block.
This one.
No, wait. Bring stage in description. This is
It's.
yeah, like we can see the command that we were talking about.
Mm-hmm.
At stage dot define prim. Over here we can see that this is how we define our prim. And first we have passed the path and then the type of the prim, right? Like if you go into the documentation again, it says that hey, what is the path we need to pass and what is the prim type. So since the prim type is XForm, right, we are using that.
Mm-hmm.
Is my voice clear or not?
It's a little muffled, but it's fine.
Okay, now how is it? Is
Yeah,
it good?
yeah, it's fine.
Okay. So over here we can see that stage dot define prim path and the prim type. And in that example, we saw slash world was the path of that thing, and the prim type is gonna be XForm,
Okay. Oh,
right?
okay. Define prim, path, and prim type. So path is gonna be
X
world,
world,
and
yeah, like the world, and
type prim
the
type is
prim
gonna be
type is gonna be
xform.
XForm.
Cool. Okay. Oh, give me 1 second. Let me see if we have any viewers. Oh, we had 3 viewers. Bro, I'm gonna be back from the restroom real quick.
Okay.
Yeah, bro. Ooh. Okay. Let's continue. So,
Mm-hmm.
hmm. Specified. So okay, we basically defined a prim over here by using this define prim. This is the path. This is the prim type. So next one is specific to USD geom schema. Use to define.
So I think we can get some more example in our well. I do remember. So if we second file, I think not this. Otherwise, we would have to, go down, go down, go down. Yeah, there we go.
Oh yeah.
Yeah. So we have defined define over here in the same manner. I think let's paste some of these commands from over here, not but just the last three would do fine. Not everything. Why? Because those they won't path defined. We have to define those paths. Like just
Oh right.
I'm trying to see if it
Oh
loads.
shit. It won't load over here, bro. But wait.
Wait, do stage children instead of prim. Do stage. Oh, I think go back. Go back. Window. Yeah. Let's see why. Why are we not able to pick up prim? Hmm. I think we might be missing out on something that they have not talked about over there. Oh, it says prim not with children. I think we need to import prim. But I'm assuming there might be import library that imports prim. Let's say AI tool. Is there any import for the same?
They're not importing anything. They're just importing from Pixar, USD from Pixar.
No. Wait. USD state to define prim, state to define. But over here they are only defining. But how are we loading prim? That is the question. Right? Down. If you go up, like this is stage is this stage is fine. Like, but if you
Mm-hmm.
go up here, prim dot get children. Where are they defining that? That was my question. So if how do we define that
Oh
part?
wait. I think they are not telling us to run it because over here
Yeah,
it's
yeah,
gonna.
I know. They are not telling us to run it.
No, because this is going to work after we create that prim and retrieve the
Yeah,
children of a
so we
prim.
created the
So
prim,
I
right?
think there are no children over here right now.
But so the thing is, prim is not getting defined. The problem, like our not doesn't know what is prim over here. The red squiggle marks is coming on prim, on
Oh
the dot.
wait. I think.
Red squiggle marks are coming on prim.
Bro, wait.
Over. It's the same. I know it's correct.
No, wait. Stage comma path.
No, dude, it won't work. It won't work. Dude, do you know how compiler works in Python first? It
Oh
won't
yeah,
work at
yeah.
any point because Prem is giving you a squiggle marks over there.
I know, bro.
Then how can you expect it
Array,
would
bro, I
work?
was trying something else.
The initiation is not, if your object or if your variable is not initialized, how will it? If you try anything, it's gonna break over there only.
Yeah. Um. Yeah, we can ask.
Yeah, that's what I said. Like, I think we have to ask AI on how do we define it and how do we treat the children. But since we don't have any children, we will definitely get empty value back. But that's I'm trying to see how we can define it.
Which number block is it? Fine. Oh wait, is it gonna be stage dot prim?
It was stage dot from, yeah, that could be. That could be. Hmm. That could be, but no, it is not.
Still showing error.
Just give it to dude. Just give it to AI. It will tell us how to resolve.
What?
The output. Okay, so what do we have? We got stage.
Okay. No, it's fine.
Dude, it's gonna work for sure.
Over an existing USD stage from disk node, ensure the file exists or use USD, blah blah blah. First page.
We are not defining the prim. Okay,
No,
okay,
they
okay.
are they are just storing it in this
Oh, so
variable.
this is the third one. You have to get the prim. I think if you do get stage dot like press enter,
Yeah.
stage dot like stage dot path,
Stage dot what?
get track. prime PRIM dude. P capital. Just copy the fucking stage. It's right over there.
What? What are you, bro? Oh, this?
Do it. And now bracket
Uh-huh.
inverted
Yeah.
slash
World.
word dot like not. Sorry, my bad. Go back. Tell it. Out of the brackets. Out of the brackets.
Oh, out of the
Brackets
brackets. Yeah.
dot get children.
Get all children or just get children?
You can do whatever. We can get all. So this is how I think we need to call it, and what it was saying.
And then how do
You
you
have to print it. You have to print.
print, right?
Yeah, like print the stage. Just put it in the print.
Yeah.
There we go. It okay. Yeah. No, no.
No, this
That's,
is the
that's
first
the
one.
bound. Like,
Yeah, this one.
because it's an object. I think that's. Oh, I know. I know. Why it's throwing the object. Dude, you do not have. You need to put brackets.
Where?
Get all children. After the get all brackets.
Oh,
Yeah. Now it will. I think give a.
yeah.
Yeah. There we go. There we go. Uh-huh.
So there are no children right now. That's why it's
Yeah. There are no children.
okay. Mm, this is insane. Okay. Oh, we have first comment, bro. All the best by Sid Hart.
Wow. Who's this? Oh, I know who is it. I know who it might be. Wait. Let me take a look.
It's not Abhishek if you think it's Abhishek.
I know, but you said some name. Who commented on it? I don't.
Sid Hart. 8905.
Uh, where can I? Okay, I think I'm not in comments.
What?
The comments.
Chat, bro, chat. Go to the
Oh, in
live.
the chat. Oh, I don't know who this is then. My bad. My bad.
Cool, we can move forward now. Specific to USD geom schema. Okay, we did this. Retrieved the children. Return the type of the prim. Helping identify. So get type name. We did not get a type name. Oh, we did. Print. Okay. One, two, three. Prim type was X form. Okay. And then prim properties were like this. Prim dot get properties. Prim dot get type name. And for this to actually work, we had to store the stage dot get prim path inside the prim variable, and only then it worked. And then we needed to store children in like prim dot get children in children over here. And okay, and then oh wait, dude,
What? What happened?
oh wait, I forget that this is a fucking IPYNB notebook. I always do shift enter to just go down. 1 second.
Mhm.
Prim dot get children. Why did we have to do all that shit? And we could have just did this over here.
You wanted to do D6 and all that shit, right? That's why.
Bro, that's what I was thinking. It did the same thing
You are
that you.
you are only one like taking it slowly, so
Cool. My bad.
fundamentals.
It was my bad.
Yeah, all your fault.
Cool, 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 cool. Okay. So this basically returns the type of the prims over here. Type was xform. We're gonna learn more about what xform is in the future modules. Um, Type and then properties of the prim were basically USD prim world get relationship proxy prim USD. I don't know what this is, but it is some sort of visibility X form OP order stuff like that. Um, but yeah, let's move forward. So example one, defining a prim. We already defined a prim. To create a generic prim on the stage, we use define prim that we already did over here. Uh, like this stage dot define prim.
Mm-hmm.
USD dot stage create new stage. This is what we learned yesterday. So by default, the prim will be typeless, meaning that it's just an empty container. By introducing a prim type, we can begin to dictate what kind of data the prim contains, depending on if it is a prim to repeat to represent a cube, a light, a mesh, etc. Okay, so this is where we created a new stage, assets prime.usda. So this usda file will have this new stage, define a new, and then basically the root layer will be named prims.usda over here. Define a new primitive at the path hello on the current stage. So a new primitive at path hello will be defined using the define prim like we just did over here. Yeah, stage dot define prim. This is the path. This is the type. So it's they just gave it a path, not the type for now.
Yeah.
So what is the default type that it gets when we define it like this?
There's only one way to find out. Run it.
Okay. Define a new primitive at path world on the current stage with the prim type sphere, and then do stage dot save. Okay.
Don't give a cloud code IPv access. Like, dude, it's gonna mess up. Don't give it right now.
It's
We
gonna.
are trying to we are trying to run the blocks. We are trying to run the blocks. Keep it like that only. Don't put cloud code in it right now. We can use anti gravity or any other thing.
Bro, but
Cloud
it's
code is
not bro, the thing is it's not rendering the sphere or any shit that you want to render over here.
where is it?
Okay, let me show you.
Yeah.
Code.
Uh
We'll just copy this.
huh.
Yeah. We don't see the thing over here.
Okay. Go back. No. Go back onto that. Go down. Go
Wait,
down.
one
No,
second.
no, go, dude, go down over there. I know what can be the issue. Like it's just gonna create the file. Rendering is something different.
Hmm.
Oh, I know. Okay, okay. See, that's the file it created.
Yeah, yeah, but this is the render also it created. See.
Wait, go up. State dot save. Wait. Speed define full speed. Hmm. I think in IPOM, there was something that we have to figure out. We are missing a library. Yeah, go ahead. Yeah, go ahead. And I think that code can do it. But for for sure, I know there was a reason. I think. But go ahead.
Display USD. See, this is where it should have rendered it, but for some reason it does not. Brother.
Yeah,
Yeah, we're not able to render it right now. We need to figure that shit out.
give it a cloud code. The rendering part is because of some library that you are missing. I think I had the same issue in environment, and I was able to fix it somehow. But the problem was with one of the library or any package that we are missing in our Jupyter notebook. That's why Jupyter notebook is not able to render it.
Okay, whatever. We can just see it over here then. I'll
Mhm.
fix it later. Um,
Mm.
so we basically created a new stage, defined a new prem at path hello, and then created a new primitive at world called a sphere, which is I think somehow defined, and it just picked up.
Yeah, it's already defined.
Okay, so it already knows that this is a sphere, and def sphere is world. Okay, note in USD output the prim with the name hello does not have a type, but the prim named world has a type sphere. Okay, defining a sphere prim. While define prim API provides a generic way to create any type of prim, many prim types have specific API to create and interact with them. File path is okay. Okay.
Mm-hmm.
Create any type of prim. Many prim types have specific APIs to create and interact with them. From Pixar import USD geom. File path is sphere prim.usda. Stage is usd.stage equal to create new stage file path. Define a prim of type sphere at path hello. Sphere usd geom sphere equal to usd geom sphere define stage hello.
Spear.
So this is
Mm-hmm.
the type hint sphere
Uh,
usd.geom,
Geom library.
yeah, dot sphere equal to usd dot sphere dot define stage and then hello. So basically they're setting the sphere at path hello as the prim type, and then they save the stage. Okay. Def sphere hello double radius equal to 2. In this example, usdgeom.sphere class to create a sphere type prim and set some data about that sphere. We set their sphere's radius to 2. Using the USD sphere class provides a more transparent interface for sphere prim type. We set the sphere's radius to 2 use cool.
Mhm.
I just need to use class to create a sphere type prim and set some data about that in the sphere. Yeah, about the sphere, we set the sphere's radius to 2 using the USD geom. Yes, alkaloid more transparent interface for the sphere prim type. ठीक है. All right, that's valid.
Mhm.
Um,
So okay, how do we do hierarchy? That is one of the important. Geoscope, the geoscom.geoscope. Define the scope. I think that's what it's right. Yeah, we are defining the scope. We what we are defining. Then we define the X. So whenever we are using the library, we need to use XFORM. Understand right now? You said that right word XFORM. So I think XFORM is helping us to geometric values into our prim. What my understanding is of now.
it's short for transform. Is a specific type of prim used to move, rotate, or scale objects in your 3D scene. Think of an XFORM as a smart folder for 3D objects.
Yeah, that's what I said. Like basically, we're storing uh, values of objects into XFORM, right? Let's drop multiple. For example, if you have four leg prim and a top, all put them XFORM. Oh, I see. I see. Mm-hmm.
Mm, cool.
Mm-hmm. Okay.
So
Move to the
basically, a folder that can be moved, rotated, or resized.
Bro, can you read this and explain this code?
All right. Mm, the first two lines are simple, as we went through. Those are like file paths, and then we are focusing on creating the new stage using that file path by passing that argument over there, right? Once we have our stage defined, right, then we are trying to get the scope defined of our trim, and for that we are using geometry as our trim type. Yes, yeah, yeah, that's what it's saying. Yeah. So I think when we use USD geom dot scope dot define, we first define our stage and then we define the prim type. That is going to be geometry, and then we are trying to load. Okay, so now what we are trying to load is, so we are now defining. Can you can you do a horizontal scroll? What is the last thing say? Yeah. Okay. All right. Uh-huh. Okay, 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 okay. Got it. So yeah, we are defining, I think we are using XCOM to define our geom scope
Bro,
path.
1 second. Give me one
Yeah.
second.
Mm.
Cool. My bad. I was trying to get some water.
Uh,
Let's go, bro. We need to complete this and do one quiz, quick quiz. We'll do a short quiz, like 10 questions.
hmm I don't know, dude. The second line I'm confused about. What, like they're trying to append some kind of path or something.
No worries, brother. We've got.
Yeah. Yeah, I think we don't know more. Like we need to do a deep dive more into the documentation. It's still vague.
Hmm.
I think what based on my understanding, we are basically trying to append the path
You see.
into in, into our X form, and then we are trying to create a cube by by appending the box into the path. Oh, I get it, I get it, I get it. Oh, it's simple, it's simple, dude. It's really simple. Go down. I know what does it mean. Go down, go down, go down.
Yeah.
Okay, yeah, dude. It's really simple. Can you go a bit up so that I can
Okay,
visually
one
show what?
second. Let me. So we are doing this one, right?
Yeah, yeah.
Okay, wait. Runs can contain other. Mhm. File path. Okay. So did it create this file or did it just define this file path?
Which
This one, the assets.
so whenever you use create new stage, it's gonna create a new file.
Oh, okay, 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 okay. It just defined the file path over here and then it did create new stage over here and then it fetched the file path from here. So this created a new prim hierarchy. Okay, okay, okay. And then define a scope prim in stage at geometry. Um, a scope prim in stage at geometry. Okay, geom scope is this is type and USD geom.
So
This is,
I'm gonna it's really easy. I got it. What they're trying to do. It's all about appending the paths and everything.
one second, one second, one second, one second. I'm just trying to understand myself first. So this is the schema, and then they're setting it to define a new stage at geometry. Then they define an X-form prim in the stage as a child of geometry called group transform. So over here, do USD geom X form equal to USD geom X form define. This is the stage. Then geom scope dot get path dot append path. Oh, get transform. Oh, so you're gonna explain me this, right? What they did about append path.
Just go down, you will see it.
And then, okay, how did they do that?
So basically, they defined, they created the geometry.
Yeah,
Then
I
they
know. And then they defined like
they
they
did
did
some
some
coding
coding over there to define it under there.
path. So it's also like initially how they explained, right? It's all about layers. So yeah, right. Okay. Staging. This is what you defined, right? And now you have created your USD staging, right? You have your stage. You put multiple layers. First layer that came over is the geometry one,
Yeah,
geometry, right?
yeah.
Now created a new sub geometry that was called group transform inside it. Over here now you have your group transform, right? Now after that you try to also append the transformation for the cube as well. There goes your cube. This is not a cube, but there goes your cube like this. So this is how they have designed the hierarchy, right? So basically, once we have defined the hierarchy, then we try to append different things onto it, and based on that, what they did was they appended an X form. The most important thing is to create an X form, right? If we don't create an X form, right, then we won't be able to store the data, because X form is specifically meant for use making sure that whatever you're defining are getting stored inside it, right? Now once we had our X form also created, then we were like, okay, let's add more into it. So we added a box into it, right? So if you go and look at the code,
Uh-huh. And so
yeah,
they find a box inside it
now in that box what we can have attributes that
about the
about
box, right? Length, breadth, height, all that stuff.
whatever you want, color, it could be anything else,
Yeah.
right? So I think it's pretty much all about defining, but defining those layers out. But if you want to know that, okay, what does group transform do? I said it's a tool, so we can ask AI over there as well. That what does group transform do?
Bro, 1 second. Your feed is getting cut a lot
Holy shit,
or something. Bro, we gotta find a good alternative for Video Ninja. I think that's the problem.
I think yeah, that's I'll I'll look in the morning then.
Yeah.
All right.
Okay, let me. So USD Geomax Foundry. I know what the code is doing. I know that it's basically defining the hierarchy.
Yeah, it's layering and
Yeah, yeah,
you know,
yeah.
when we say layering, like that is the most fundamental thing over here. You know, like we are basically layering our cake out,
Hmm.
and other X forms, and then we try to put in more X forms.
So something like this.
Yeah, not like this. Like it's box inside box. So the other thing would also come in place.
Oh, okay, okay, okay. I think I get it. So, okay, so this big box is the geometry over here. This X form is scope is geometry, X form is group transform. So this box will be group transform, and then
Mhm.
finally the cube would be inside this.
Yeah,
That's the
that's the
hierarchy.
so if, I'm also understanding that it could be like in the code, we can also change the name as well. Maybe like if you don't want transform, if it is something else.
Yeah, the type, right? Type.
Mm.
Let's ask the god himself now to explain this simply.
Asking if we change the name, what will happen?
Wait, one second, one second. Create the root. Yeah.
When calls.
Create the child, the branch, X
Oh yeah,
form,
see, we are basically creating a path. Yeah. Mm-hmm.
define. Uh-huh. USD geom dot xform dot define stage append path group transform. Cool. Okay. Bro, explain what is it doing over here? Geomscope dot get path. What does this do?
It says the key points. These are
Yeah,
the
I
important.
know. Fine, I know that that's where we are append. I know what this is doing, and but I just
So
want to know why we are doing it with geomscope dot get path. Oh wait, how instead of
there. That's what I'm saying. It says there.
okay, get path. So it just this it uses to get the geomscope's
So,
path, which is
so
geometry and group. Okay, I got it.
so basically, even if you don't put the path in,
Yeah, it's
the
gonna work. It's gonna still work. Yeah,
it's gonna still work. Why? Because you have inputted the path,
yeah.
right? And for scenario, let's say you don't use geom.scope, that thing, and you just append it. I think it's just, it will just put it into the layer. That's what I'm assuming.
And then now it's gonna do USD geom cube dot define stage xform dot get path same and then append path box. Yes, sir. I got it. I got it. Perfect. And tell me one thing. So is there some library that already like predefines this USD.geom, USD.geom.xform and USD.geom.cube or something like that? Like, are these predefined?
Yeah, those are predefined. Like these, that's so geoscope and all those things that you can do whatever you want because it's just an application. You can put cube, you can put cube underscore one, you can put xform underscore one, whatever you want.
Mhm.
But make sure that the code is readable and going to be understand is under is like readable for other developers, and they are also able to understand what you're trying to do. So that's why they're trying. They have kept it like geomscope, xform, and all those things. But the thing we cannot change is usdgeom.scope, usdgeom.xform, and usdgeom.cube. Why? Because of the same reason that they are predefined libraries and we cannot change them. We can just like put a case that hey, we can import USD as U, USD geom as UG or something. That
Mhm.
would work. But apart from it, changing the type names, like making the xform notation to xform underscore one would work fine.
Okay. Okay, let's move on. I think we've completed that.
Yeah.
The prim hierarchy that we have created is geometry, group, transform, and cube. Cool. By nesting prims in this way, hierarchical scene graph begins to take shape. In this example, geometry is the root prim. In other words, geometry is direct child of pseudo root. We are also defining three different types of prims here: scope, X form. Oh shit, I accidentally clicked on it, but that's fine. Scope, X form, and cube. We will look at these prim types more closely in other lessons, but for a brief description, X form defines a transform, translate rotation scale. Scope is a simple container that does not hold transform data, defines a primitive rect rect rectilinear cube. Okay. Does the prim exist? When working with large amounts of data, it is key to make sure that the prim exists before trying to override it. We can get the child of prim using getChild. Cool. Yeah, that we tried already in the notebook. If it was unable to find the child, it will return invalid USD prim. An invalid prim will evaluate as false when treated as a boolean. You can use USD.object is valid to check if the prim is valid or exists. Cool. So over here from Pixar, okay, file path, it defines this prim usd.prim stage dot get prim path. Cool. It got a prim path geometry. Got get prim at path geometry. Child prim USD dot prim. If child prim is not equal to uh prim dot get child box, print child prim exists. Else, excuse me, mm, child prim does not exist. Do you want me to run this block?
Yeah, sure. Yeah, yeah.
Bro, what the hell? Oh wait, we already have this.
Yeah, I told you, dude. That's how I knew it. That we do, like over here in our the file or the PR that I created. It's so valuable. You don't know, dude. You don't know. NVIDIA is lacking one thing. That is my PR mode.
The fuck?
Although for some reason, those bastards.
What the fuck?
Guys, please, who is watching, please approve the freaking PR.
There's only one guy watching right now. I don't know who that is, but
Yeah, if you are watching, just go to NVIDIA's Learn OpenUSD, and you will see a PR over there with the same notebook that I have created and we are using right now to learn everything. You can also fork that repo if you want.
it's not working, brother.
What's not working?
Look at
Dude,
this.
because your file path is not defined properly. Change the name. Change the name of the freaking file.
But it should. Oh, yeah. Prime 4.
What broke now? What are you doing?
I'm just trying to understand what file path does it require over here.
Run it again. Run it again.
I think we have to do create new, right? Or something like that for this.
Does the
Because
file? Oh, the file exists over there. Wait. Go back.
this is the file.
Yeah, the file exists over there. Go back. Prime. Open it, right?
Oh,
But
wait. I think I know. Mm,
no, dude, we our error on the line four, not line four.
yeah, got it.
Nothing open.
Yeah, that's what line 4 is. This is line 4, bro.
Look at the exception.
Oh, this one. Yeah, my bad.
Attempt to find. Okay, main. Okay.
Oh my god.
This shit. Mm, what could be the example? Okay, just copy the path and just
Copy which path? This one.
yeah, copy the path or copy the path. Yeah, just put might be that. It might be that. There we go.
But there's a new error.
There's a new error.
Invalid prim. Yeah, that's what I thought.
Mm.
This needs to be fair, I think.
No, 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 no. It's not about that. Wait. It's about access invalid null prem. Our prem is empty. The thing is that our
What?
prem is
What?
our prem is empty. Like it says access invalid null prem.
Mm,
Right. So what is it over there? It's spear. Okay. I think it's gonna be spear. Yeah. It's gonna be
bro,
spear.
I told you.
Okay, man. My bad.
No,
Invalid null prem.
nope. Uh,
Holy shit.
hello, I think.
Small. No, it's not caps. Oh, I think I knew the error. Dude. Go to that prem file,
Yeah.
USDA. Go to
Oh,
that.
no, wait. Yeah.
No. Go to that USDA file. If you can you edit this file? Edit it. Move the spear into the hello.
Yeah.
No, I don't know. I think let's use AI.
Mm. Oh, wait. This ran successfully over here.
Change the name. The name change. Is an issue. Like you the correct the related.
But I think I get it, what it's trying to check.
Yeah.
So it's fine, yeah. Okay. Child prim does not exist. Here's the USDA output asset prim hierarchy.usda to verify. To verify def scope geometry, box is not a child of geometry. If we change box to group transform, then it will print. Oh, I see. I get it
Is,
now.
oh, is it because it's not an X form? Is it because of that? You think? Can you go to X form like our USDA file over there? Go to info.usda. Put X form in the def. Go to def like on the thumb. Right X form. Yeah. Let's see. Do it. Try to
Mhm.
save that file. No, you haven't
Oh
saved that
no,
file.
my bad.
Yeah. Yeah. Try now.
Mhm.
Oh.
Yeah, whatever. I know what it does though.
Mm-hmm.
Scope. Okay.
Wow. Holy shit. Yes. Whew. Dude, you know, it's running with my auto job application tracker and it's working flawlessly now.
Hmm.
I had a couple of issues, but now that's working fine. All right. So what we learned today, I think we learned today that how do we fail with this freaking thing.
Hmm.
Mm-hmm.
Oh, it's done.
Is it because our scope is geometry? Do you think? Is it because our scope is geometry that's why our
Bro,
scope
I
is
think
failing?
we're not running it in the correct sequence. That's it.
Now, when over here in this file, you can see we have depth, scope, geometry, we have depth, xform, group transform, we have depth, cube. Yeah, work. Copy this into this file. I think it should work. Dude, you have moved that. Dude, we need IntelliJ 1.0 on the top, I think. Yeah, this after this. Yeah. All right. Let's try now. And why, dude? You have to. We do not have to change anything. Mm, dude, we do not have any box over there. Okay, we have box. My bad. Mm, holy shit! What is this? Get child path. Why is this thing not running? Just ask AI once used.
Hmm. Bro,
Mm-hmm.
do you want to do like a quick quiz now?
Yeah, sure, sure, sure. Ask him to generate a 10 or 12 max.
Bro, I don't think it will generate like a good one because it does not have prim.
Let's see what it generates. You can add the source to random as well. It's AI. So,
Bro, that's what I was trying to do initially, and you're like, "Hey, it's gonna
right,
hallucinate."
you clicked on that fucking generate quiz button, right? Or me. So that's on you. Not
Bro,
initially
initially I was
I
trying
had
to
to add
add
the
the
fucking
fucking
prims
Prims
that
webs. Oh
to
my
do a
god,
file.
bro, you're unbelievable. Oh my god, my god, bro.
You can always correct yourself out.
Shut the fuck up. Chod. No, I'm not gonna open this one. I'm gonna delete all of these.
Exactly. Oh yeah, now do it a quiz.
Alright, come on.
When using generic defined prim method in OpenUSD pipeline without specifying it, what is the resulting state of the prim? Hmm. It is created as a scope. C can be an answer. The method returns an error because type is mandatory argument. Like I haven't seen an example over there that says
I think
that
it's
they
A. I think it's A.
it is created by a typeless implementer. Okay.
Yes, sir.
Yes.
Because you see over here, you're creating these prims. Before that, it did not have any types over here. Because you see, when these were created, they didn't have any types.
No, dude. Go to that staging. I will show you what. It's not gonna be the same. Like if you even if you use corporate, I think it should be completely empty then because
No, but typeless. It's saying typeless, not empty. Like empty container, but
not empty.
typeless.
Don't say empty container. It says right over there. It default and by default it is
Typeless. Typeless.
okay. I get it. I see.
Okay. If a prim exists at path, root, parent, child, okay, what will be the result of get child, child on the prim object located at root? Prim object located at parent.
So prim exists at the path. What will the
I think C, right? It's gonna be C.
yeah, I think wait. Hmm. It returns the USD prim object for via recursive search. What will the result of get child on the prim object located at root? I think it should be A, but because it is a nesting node ancestor. But yeah, I think yeah, it should be C. Let's go with C.
No.
Oh, it returns an invalid USD prim object. The get child method only returns direct children of the calling prim since the child is the grandchild of the root.
Oh wait. Oh, get child, child.
Oh,
Oh, we missed this, bro.
that's how they get you.
Tricky questions. These are tricky questions.
Yeah.
Mm-hmm.
In OpenUSD, what is the functional
C.
key
I think
and
it's C.
and the X from prime?
It's C, bro. Very
From
easy.
oh yeah, it's gonna be C.
Yes, sir. Without transformation attributes.
How many questions has he generated? 10. Oh, nice. What is the recommended way to verify if a USD prim object exists? Is valid with Python API?
To verify if a USD prim, comparing the prim, I think C again. We just did this, right?
Okay, we did this. I don't remember. USD dot prim.
Bro,
Wait, is valid?
does prim exist?
Yeah. Where does it say
Oh
valid?
yeah, there is no function called is valid. My bad.
I would do remember it. So C is eliminated for sure. I think D can be an answer.
Get name. Checking the prim's path starts with a forward slash. I don't know about that, bro. Hmm. Mm, what do you want?
I would go with D.
Hint. Consider how OpenUSD handles the evaluation of objects that point to non-existent data. It was C, motherfucker. Holy fuck. What's the fucking time? It's four.
So
4 in the fucking morning. You wanna do like till 6?
my ass.
My ass? You're gonna show your ass?
Yeah, I'm not gonna do anything.
Come
Just
on, in the chat. We wanna
no,
see
nothing to do.
Gavinder's ass. Bro, I'm kidding, bro. I'm kidding. I'm not gonna, bro.
Just do
Bro,
on something.
bro, I'm kidding. I'm kidding. I don't wanna do it. I'm just gonna finish this quiz and
Yeah. I don't have any problem. We can do a stream, but it should start earlier, please, bro. Like we started very late today.
yeah, but it's like it's blitz
No,
scaling
no, it's not
season.
that. No, never, never. It's not good. I'm on a sleep schedule.
Hmm,
It's getting fucked. I can see, but I don't want.
I see. Okay, so what was the issue, bro? You didn't interpret the question over here.
Yeah, bro. Lack of knowledge. Of knowledge. I would say that.
What is the recommended way to verify if a USD Prim object exists? Let me ask this question over here, bro. Like, why the fuck did we not get this one?
What the hell are you doing right now? I thought you were using the prem.
I was just trying to see where that shit was. Like, why did we not get it?
Why are you calling the shit?
No, bro. I'm just trying to see if there was like one example of related to this over here.
Oh, that's what I'm saying. Use the freaking AI to tell us that was there anything or not.
Example four. It's saying example four. Bro, that's what I showed you, right? Oh, they. Oh my god, bro. I even came here and I was like, oh shit, bro. I should not have listened to you. I was. I thought I saw that over
You
here.
came over here and then you went over here, right? On the
Yeah, I saw this, but I didn't see this one over here because they didn't use it in the code anywhere, right? That's why I didn't remember that. Fuck man, Shant. Fuck yeah, Shaj.
what if he comes and watch, right?
Bro, why the fuck would he come and watch our stream, bro? Like out of everyone.
You out of random, if somebody searches about this or open anything related to it, he's gonna recommend it.
Bro, out of
And you also have
7.8 or 8 billion people.
next to it.
Whatever, fuck that. Uh,
The final object, is it advantageous to use geom.cs to avoid differences? I think it should be default. What do you think?
mm, necessary material prims for rendering material
Yeah, material is like
creates a
everything that is
mesh.
trying to render, right?
Let me see where we did this. Mm, I think it's gonna be C.
Okay.
What?
B, it provides a specific method for that front type. Schema class will offer convenient methods with type specific attributes like radius or extension. Dude, this was a GID question. You like okay, so over here we can see the USD geom.sphere class is the only way to assign a radius to the prim. That is also kind of correct, but that is not properly used, right? Because in the prompt it says it provides a specialized interface with specific methods for that prim type. So it is like more specific to that.
Mm-hmm.
And say attributes like radius can be authored manually on generic prims, but it is more cumbersome. So that is also correct C, but based on what options we had, the B was the most obvious one. I'm assuming.
Excuse me. It provides a specialized interface with specific methods for prim type. It's like offer convenient methods to interact with type specific attributes like it. So the okay, excuse me. Got it. How does the OpenUSD hierarchy categorize a prim that is authored directly under the forward slash character? Excuse me. Did you read the question?
No, hierarchy category prim that is authored directly under the forward slash character.
I think it's gonna be D.
Wait, do I say reader again? How can it be D?
What you think it's gonna be A?
Yeah, because saying that if it's directly under the forward slash character. So I'm assuming that the whole path is empty. So if the path is empty, it refers to whatever you're gonna like put in is gonna be default. That's
I
what
think it's
I'm
gonna be
assuming.
D, bro.
Okay.
I'll do A. Let's see. Bitch, let me show you where I read it. 1 second. I remember read it yeah, over here. Geometry. In other words, geometry is direct child of pseudo root. Yes, sir. By nesting prims in this way, hierarchical scene graph begins to take shape. In this example, geometry is a root prim. In other words, geometry is a direct child of the pseudo root. Biatch.
Mm-hmm.
So pseudo root is gonna be the first thing, and then yeah. True or false? Oh, this is new. Of a prim's unique path, such as world building wall, is primarily used for identifying its location in the scene graph and cannot be used for referencing. It can be used for referencing, right?
Yeah, I think it should be false. Maybe.
Let's read one more time. Mm. But it does not say that it can be used for referencing, so I think it's again a GRE type trick question.
Hmm.
Oh, it's a trick question, bro. It can be both because we don't know if it can be used for referencing or not based on the information we have. So let's see what's a recall it for you or bring specific. Oh, false. I think it's got to be false.
Do it.
Yes, sir. Critical because yeah, we can transfer prims in multiple USDI files and use it multiple times, right?
Yeah.
So it's definitely possible to reference it in different
Mm-hmm.
locations. Which of the following best describes the role of a prim as a container in OpenUSD? Of the following best describes the role of a prim as a container. No, what is the physical box parallel collision detection? No, it can only draw. No, yeah, I think it's gonna be D.
Yeah, it's gonna be D. Based on the other options, nothing works.
Mm-hmm. Yes, sir. It is a node that encapsulates attributes. What happens when you add a prim type to a previously typeless prim on a USD stage?
Hmm.
You add a prim type to a previously. Trick question, bro. I don't know this one. I have no idea.
If the prim type changes, what happens? If the prim type changes, then if it was a sphere, okay. But if it is typeless, I think we cannot.
I
I
think
think
it's gonna be B.
B, the prim begins, but it says prim begins to dictate what kind of data it contains based on the type schema. But what if it was typeless?
Yeah, that's what it's saying, right?
So yeah, that's what I'm saying. So if it doesn't have a schema, right, and if you change it to something else,
Mm-hmm.
you're saying that it's going to dictate.
I mean,
I think all so D is eliminated. C, the prim's path is automatically renamed. Hmm. I think it's gonna be either A or either B, but the stage must be reloaded to recognize the change.
reloaded. How do you reload a stage?
I think refresh.
No, like, does is the USDA file gets generated again or something like that?
USD file. So you remember like yesterday we were discussing that until unless you don't put save, your
Mm-hmm.
file doesn't get
Mm-hmm.
saved, right? So I think whenever you put save, your file gets regenerated, right? So
Mm.
that's why I'm trying to go with A.
Okay, let's do A. Oh, it was B, bro. I told you.
Yeah.
Yep. Attributes and behavior expected of that prim.
Mm, nice. In the hierarchy geometry,
Root level ancestor. Yep. Done. We're done for the day, but we scored 50%.
that's fine.
But no, I answered like couple of questions that you said, and I was right.
Yeah, I know. It's on me. I know. That's fine. What can I say?
Topics covered. Keep learning. Hmm. Okay. What do you want to do now?
Drugs.
What? I don't support all that shit, bro.
Fuck you.
Please.
Fuck you. Yeah.
All right, guys. That's it for today. I'm gonna end the stream now. चल भाई हो गई ओ भाई 68 views माँ चौथ दी भाई